Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 academic students who are studying the measurement and geometry unit. It's video number 3 of the geometry portion. In the other two videos, we reviewed important concepts about angles. For example, there are 360 degrees in a circle, 180 degrees in a straight line, and 90 degrees in a corner. We reviewed that the sum of the interior angles in a triangle is 360 degrees, and that the sum of the interior angles in an n-sided polygon is given by this formula. Now what that means is, if you have, for example, a 5-sided figure, then you can substitute 5 into this formula, and it will tell you the sum of the interior angles. If you had a 18-sided polygon, you could substitute 18 into this formula and find the sum of the angles. So there's a clear relationship between the sum of the interior angles and the number of sides for a polygon. That's where we ended the last video. So I want to start this video with a question. We know how to find the sum of the interior angles of a polygon, but what about the exterior angles? So let's talk about what exterior angles are, and then we'll see if there's a pattern to the sum of them. So first of all, an exterior angle is found like this. First of all, you extend each side in a particular direction. So in this case, I'm going to extend in a counterclockwise direction, and then I'll do the opposite next time. Doesn't matter, as long as you're consistent in one question. So for example, I could not have extended this way, and then decided to go like this, right? Because then I've done something very strange because I was extending, and then suddenly I went in the other direction. So you have to extend in a constant. You have to decide which way you're going and then just keep going. So I decided to go in this way. So what I've done is I've created exterior angles here, here, and here. And those exterior angles, well, we can certainly find what they are quite easily because every time I extended a side, I created a 180-degree angle. So I can do 180 minus 43 to find this angle. And I can do 180 minus 66 to find this angle. And I can do 180 minus 71 to find this angle. So for this triangle, those are my exterior angles. So let's see what the sum is. 137 plus 114 plus 109. If I add those together, I get 360 degrees. Okay, now obviously we can't jump to conclusions. Let's look at a different triangle and see if we get something similar. So here's another triangle. And again, I want to talk about the exterior angles. So we're going to extend them. And this time I'm going to extend them clockwise. So extend, move clockwise, extend, move clockwise, and extend. So I've extended my sides to create exterior angles here, here, and here. So now I can use the 180 rule to find the measures of those angles. So 180 minus 35 is 145. 180 minus 37 is 143. And 180 minus 108 is 72. So what is the sum of those angles? So adding 143 plus 145 plus 72, what does that give us? It gives us, again, 360 degrees. Okay, so it definitely looks like there's something here to the sum of the exterior angles in a triangle. So let's look at a 4-sided figure, a quadrilateral, and again, we're going to extend all the sides. Extend, 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 and extend. And of course, every time we extended, we created a 180-degree straight line, which means we can find the value of each of these exterior angles. This would be 120, 87, 180 minus 87, so that would be 93, 180 minus 75, and 180 minus 38 is 42. I almost said 52. So what's the sum of these angles? So 105 plus 42 plus 120 plus 93. What do you get when you type those into your calculator? I get 360. Hmm. So the exterior angles added to 360, added to 360, added to 360. That's actually the rule. It doesn't matter how many sides your polygon has, the sum of the exterior angles is always 360. So there isn't a relationship that you have to solve for like there was for the interior angles. For the exterior angles, there's no math to do. The sum of the angles is always 360 if you're looking at the exterior angles. Now, I do want to make one little point that whenever I've been talking about polygons, I've been talking about a certain type of polygons, and that's a convex polygon. A convex polygon is kind of a regular looking polygon with nice sides and nice angles. The stuff that doesn't apply. So the rules about the exterior angles adding to 360 and the interior angles adding to 180 minus 180n minus 360, those rules do not apply to this weird looking polygon here. The problem with this polygon is someone took a bite out of it. And because they took a bite out of it, this interior angle is all messed up. So our rules do not apply to that polygon. Same thing here. This polygon somehow kind of managed to cross over itself. So if you think of this as one polygon, it's not just a convex polygon. So our rules don't apply there either. They only apply to these lovely convex polygons. So just bear that in mind. Here are some more examples. These are nice polygons. So this is a nice convex polygon. This one's lovely. I like this one. But this one here has a bite out of it, so we don't do it. This one here looks like a bow tie, but it's not a convex polygon. So we only work with convex polygons, and the rules we just discussed only work with convex polygons. And again, that's not something that really is going to come up in grade 9, but it's important that you are hearing vocabulary so that when you do go on to study convex versus concave polygons, you have some background. And that's going to become very important if any of you plan on doing any sort of computer animation or computer graphics in the future. Okay, so now that we've learned about polygons, what's next? Aha. When two lines cross, they create opposite angles. So here's two lines crossing, and they create an angle here, which is opposite this angle, and they also create an angle here, which is opposite this angle. And those opposite angles are equal to each other. Not only that, but because I have a straight line, I know that those opposite angles, not only are opposite angles equals, but these two angles are going to add to 180. So that gives us, let's write that a little more algebraically. Here's two lines crossing. I'm going to call this A. No, let's call it X. Yeah, we like X. We're in high school. X. And so I can call this X. And if this is Y, I can call this Y. And not only is this X and this X and this Y and this Y, but we also know that X plus Y must equals 180 degrees. Now, you'll notice down here, this is talking about something called parallel lines. So let's add a parallel line to this. Now, this line and this line are parallel. So let's indicate that with parallel line symbols. So these little tickies or chevrons indicate that those are parallel lines. And because they're parallel, then the way that they intersect this third line is identical. Whatever this angle is must be the same as this angle because these two angles, these two lines are parallel. So if I called this X, then I can call this X. And therefore, watch what happens. When you have parallel lines intersected by a third line, which is called a transversal, then this pattern of X and Y's is always going to be true. And again, don't forget X plus Y equals 180. And that's kind of nice because really, if you knew one single angle in this whole system, you would know every angle. In fact, let's test that. So let's erase. And so I'm just going to put back on the parallel line indicators. And if all I knew was that, oh, let's say this angle here was 35 degrees, I could tell you each and every one of these other angles. By opposite angles, this must be 35. By the 180 rule, if this is 35, this must be 145. And therefore, this is 145. Now, because this line and this line are parallel, then this angle here is also 35 because the angle formed here must be the same as the angle formed here because of the parallel lines. And therefore, this is 35, this is 145, and this is 145. So when you're working with a parallel line system that has a transversal, one angle gives you a total of 8 angles. That's pretty nice. So here it is again with x's and y's. If I know this and this, then I know this and this. And I know this, 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 and this. So again, all 8 angles are known to me if I know a single one of them. Now you may have studied this in earlier grades, I hope you have, and you may remember something called, for example, an F pattern. So a lot of times you've studied these parallel line systems, and your teacher may have said, look for an F. So here's an F, and then you had to memorize the fact that the armpits of the F are equal to each other. So if you have angles in an F pattern, you have equal angles. And hopefully you know to look for an F that's not only a perfect F, but maybe a backwards F. There's a backwards F. So I know that this angle is equal to this angle, and so on. You could also look for an upside down F. So for example, here's an upside down F. Or here's another upside down F. Now, that F pattern comes from this rule about the eights. So the parallel line 8 angles, you can see that there would be an F pattern here, and that x equals x. Now, I personally prefer to think about these 8 angles than to remember F's and other letters, but it's good to see how they fit together. So again, here's another F, and therefore x is equal to x. And we knew that already. So that's the F pattern. You may have also studied in a previous grade the Z pattern. And a Z pattern would look like this. So here's a nice looking Z. Well, it's kind of an ugly Z, and it just made itself uglier. I don't know why it did that. So let's, oops, what's happening? Okay, so where is that Z? Let me refix that Z. Here is a nice Z pattern, right? So you can see that's kind of a wonky looking Z, but it's still a Z, and therefore this angle is equal to this angle. So if you have a Z pattern, you have equal angles. And again, just like the F pattern, it could be backwards, it could be upside down. So you should see that there's also a Z pattern that looks, oops, a Z pattern that looks like this, right? So that's a backward Z, so this angle is equal to this angle. Now again, I prefer to think about the 8 angles in this system. Where did it go? I prefer to think about the 8 angles in this system, which somehow has disappeared on me, but we can recreate it, no problem. So remember the XY, 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 XY angles from here. Again, there's a Z pattern here, and we knew that this was Y and this was Y. So we knew about the Z pattern already. And in addition to the F pattern and the Z pattern, you probably learned about the C pattern that looks like this. And a C pattern is my least favorite because it doesn't tell me that I have equal angles. It tells me that I have angles that add to 180. So hopefully you learned about those F, Z, and C patterns last year. And in the next video, we're going to start to do some questions together where we use these rules.